And yet software development is quite opinionated. I mean, we are more fashion driven than the catwalk in Milano, right? And
Yes,
I
true.
should know that because I'm a software developer myself, and I try to avoid these traps, but I fall into them every now and then. So that's why we decided in CodeScene everything we do will be supported by data. And I hope if there's one big lasting contribution, then it is that technical debt management and all of that can be much more data driven. It doesn't have to be subjective and based on speculations.
Hey, Luca here. Welcome to a new edition of the Refactoring podcast, where every 2 weeks we interview a world-class tech leader. Today's guest is Adam Tornhill. Adam is the author of the popular book Your Code as a Crime Scene, and he's the founder of CodeScene. With Adam, we discussed his unique insights about technical depth and code quality, which come from his study of forensic psychology. We explored how static analysis is not enough to understand code health and why you need to look into version control history to understand hotspots, change distribution, and buzz factor. And finally, we inevitably talked about AI and how it changes, or maybe does not change, how we should write code. So let's dive right into the action. Hi, Adam. Welcome, and thank you so much for being here with us today.
Thank you, Luca. Great to be here.
So, Adam, you're the author of the popular book Your Code as a Crime Scene, and you're the founder of CodeScene as well, which is a great tool to manage technical depth and improve code quality. And I'm excited to have this chat today because I believe your work expanded how we think about software design and technical depth by applying, I should say, novel ideas from unlikely domains like forensic psychology, for example. So I'm excited to explore some of the underlying ideas and principles behind your work.
Yeah, sounds good. It's been a long journey. I've been doing this thing for almost 30 years now, writing software, still enjoying it, and most of the time my code even works. So I'm happy.
Yeah, and I want to learn all of it. So we usually start these chats by asking our guests about their journey in tech, which I feel is particularly relevant in your case, as you have a quite peculiar background. So can you tell me more about it?
Yeah, sure, I'd be happy to. So actually, I started at a fairly young age in the late 1980s on a Commodore 64, lovely machine. I still code on
Yeah.
it every now and then. And developed games and some side projects for roughly 10 years. So when I started to work in the mid 1990s, I already had a decent grasp on coding, or at least so I thought. But I joined a larger product company and I quickly realized that what I have been doing in isolation doesn't really translate well into large scale development. There are so many other factors. And for once, I couldn't understand the whole system, right? I could no longer hold it in my head. I only had a small window into a large code base.
Yeah.
And I worked for a couple of large companies for a number of years. And a pattern that I saw was that most software projects tended to fail. And they tended to fail miserably in like delivering late, below expectations. And it kind of surprised me a bit. So I wanted to figure out, why is it so hard to write good code? Why it's so hard to succeed with software?
Yeah.
And I kind of thought that I won't find the answer to that within the tech industry. So I decided to do something different. I decided to study psychology. So that was how my psychology journey started. I went to the university. Originally,
Yeah.
I just wanted to do a introductory course over a year. But psychology is so fun that I stuck with it for 6 years.
Wow.
And yeah, that's how it all started. And after that tech journey, I was fortunate to work as a software developer during my studies. So I had so many
Yes.
opportunities to take what I learned in psychology and apply it back to coding. So
Yeah.
that's where the whole code as a crime scene and CodeScene originated.
Hey, before we continue, I want to tell you more about today's sponsor, which is Augment Code. Augment is the only AI coding platform built for real engineering teams, not to vibe code, but to make real progress. And that's because Augment truly understands your code base. It has a custom-built context engine that takes into account every repo and every file in your stack, scaling nicely to tens of millions of lines of code. So it can actually help to write functions, fix CI/CD issues, triage incidents, and review PRs, all from your IDE or from your terminal. Learn more on augmentcode.com. Yeah, I love this story, and I love that your engineering curiosity made you stick like 6 years with psychology. And I agree. I mean, even from my own very small perspective, it's so interesting. And I'm sure there are so many fascinating analogies with and lessons to be learned about how we think about code and how we write code. And one of the things that I absolutely love about your book, as a fellow, let's say, writer myself, even if just newsletter article, is just how memorable, the main analogy is, like in your code as a crime scene. It's so fascinating just to read the title that I mean, as a reader, you can't help but just being sucked in into your work. So how and why did you choose the crime scene metaphor for analyzing code and learn more about how good code works?
Oh, yeah. That metaphor actually came quite naturally. So I took a couple of courses in forensic psychology and criminal psychology, and I really, really enjoyed them. And I learned about the method for offender profiling called geographical offender profiling, which has nothing whatsoever to do with what you see in Hollywood movies, right?
Yeah.
Geographical offender profiling is very much based on statistics and an understanding of how humans interact with their environment, right? So basically, you look at the crime scenes, the locations of them, and based on that, you try to deduce the home base of the offender.
Yeah.
And I've been doing a couple of these as part of my studies. I've been working with some real crime series data, and it really struck
Wow.
me how fascinating it is that you can pick up a map of a vast geography, and pretty soon you can shrink it down to a small part that the forensic psychologists call a hotspot, and there's a high
Yeah.
likelihood you find what you want there. So it kind of struck me that what if we could do the same thing with software? What if we can pick up these code bases of hundreds of thousands, millions of lines of code, and within minutes identify the hotspots and know that, if we explore these parts of the code, we're very likely to find the offenders, which
Yeah.
aren't criminals, but code that's more complicated than what the problem calls for, right? Technical debt. So that's kind of where it all started.
I love this, and I love that. I mean, you mentioned hotspots, which also is like a core concept in your book and your work, and we'll get to that. But I didn't know it was exactly the same name and idea from forensic psychology. So, and if by get let's get right into it. So, one core idea that I love about your work, which seems obvious in retrospect, is uh, when we usually talk about tech debt and code health, for a long time, we have only used like static analysis tools that take into account only the final version of the code. While I think one of the core insights about what you say is that we have this incredible treasure trove of data, which is version control history, which can tell us so much more. And we are not using that, and there is so much we can learn. So why is just the final version of the code not enough, and what can we get from version control history?
Yeah, that's an important aspect. So I remain convinced that we can never understand a large, complicated code base based on a static snapshot of the code alone.
Yeah.
And I mean, static analysis, it is useful. It is useful in finding bugs and error-prone constructs and all of that. The main problem I have with static analysis is that it's inadequate to really, really help us improve and remediate bottlenecks, because static analysis lacks the most important part of code complexity, and that is impact and relevance. So what I mean by
Yeah.
that is that I've seen so many companies waste months rewriting a piece of software, and then they look at their performance metrics, their output metrics, and it doesn't move the needle at all. And what quite often happens is that, yes, they have rewritten and redesigned the most complicated part of the code, but what if that code had been stable in production for 5 years? You never need to
Yes.
touch it. There's nothing urgent on the roadmap that suggests you will ever visit that code again. To me, that's a massive risk and a massive waste. So what I try to do with your code as crime scene and later CodeScene is to tap into developer behavior. So what we
Yeah.
do is basically we analyze version control data, Git, and look at how are the developers working in the code base. And it turns out there are very strong patterns. the majority of the development work is located to maybe just 2-3% of the total code base. So if you have any technical debt in those 2-3%, which I call hotspots, then you know that that technical debt is of high interest. It's really, really impacting you.
Yeah, this is so interesting. I want immediately to tie in with something you said just now. So you said that 2 to 3% to 4% of the code base gets most of the activity. So is this a recurring pattern, that is this distribution of development activity is like always concentrated into small hotspots in most code bases? Have you found that?
Yeah, it seems to be a natural law of software. I personally analyzed probably 300-400 code bases over the past decade. And it's a
Yeah,
pattern I always find that when you look at the change frequency of individual source code files, you always see a very, very steep power law curve. So it simply
yeah,
means that the majority of your code is in the long tail. It's rarely if ever touched. And this is
yeah,
actually good news because now you can go to your business manager and say that, look, all the technical debt down here, we don't have to care about it right now. Our most urgent technical debt is in this small part of the code. So it
yeah.
gives you a window to prioritize.
So basically, what you call hotspots is saying that it's not enough to say this code is complex. It's not the highest quality it can be, but we should look at complexity and the amount of change that a code sees over its lifetime. I mean, bad code that doesn't get changed a lot or very often is not problematic, as opposed to some code that maybe it's even a little bit better, but it gets changed all the time, so it needs to be perfect not to cause problems.
Yeah, exactly. I mean, you can have long tail code that is in bad shape, and it's important to know about it because it's a future risk if you ever start to work in that area, right? But even a minor amount of technical debt in a hotspot can very quickly become expensive. You can kind of view the change frequency of a piece of code. You can view it as the interest you have to pay on that technical debt, and that can
Yeah.
quickly spiral out of control.
Yeah, I can totally relate to this because I have even a small like personal story to share. Because in my previous startup, we had one time like a failed M&A negotiations that we had, and during that negotiation, we had a technical due diligence, and the buyer brought in a consultancy that ran all kind of analysis on our software. And it was mostly static analysis, as you may imagine, and that analysis brought back a lot of problems in the code and areas of technical debt. And we had like long arguments about the fact that those areas of debt were not really relevant a lot to the code base because there were stable areas, we were not changing them often, while instead as a small team, as a small startup, we cared a lot about keeping our core part of the code base like tidy and clean. But it was a tough conversation, and eventually the deal didn't get through. I'm not sure it was for this reason, many reasons probably, but I remember being very frustrated by the fact that it was hard to understand for people from the outside just by looking at the final version of files and not looking at activity, uh, the actual state of the code base as we knew it.
Yeah, yeah, that's fascinating, and I think that brings you to, or it brings us to another important point that if you act on just code information, then you might waste so much time. And that
Yeah,
comes with an opportunity cost because you could have used that time to refactor something that truly moves the needle for the business, right? So I think it's a
yeah.
crucial perspective with that behavioral dimension.
Yeah, absolutely. I agree. And I think one part that fascinates me about your work also when now that you work on CodeScene is that you've run a lot of research and industry reports starting from data of your customers about how code health in code bases works, how tech debt works. And some of the most common criticism around tech debt work is that it doesn't bring value to the business or that value is hard to demonstrate. While you've run like hard research showing that high quality code enables both faster and more reliable development, right? So walk me through this.
Yeah, that's true. Uh, it's a study that we call Code Red, the business
Yeah.
impact of code quality. And basically what we wanted to do is that we want to make sure that, I mean, CodeScene is not an academic company, but we strongly believe in academic research
Yeah.
as a method to prove that things actually work. So that's why we have our research team. That's why we publish research. And what we wanted to do was to, make it possible to build a business case for large-scale technical debt remediations and refactorings. So we simply looked at the correlations between code health, if you have healthy code, unhealthy code, and how fast you can develop new features, and the number of post-release defects depending on the code health category. And what we quickly found was that if you have healthy code, then on average you can develop a new feature or fix a bug more than twice as quick as someone that has unhealthy code. So
Yeah.
that's already a big advantage that adds up to very significant numbers pretty soon in a large team.
Yeah. And so how do you assess code health? So calling green code versus red code.
Oh yeah, that might be a long story. I'm going to try to keep it short.
Yes.
But basically the problem is when I built CodeScene, the first version of it, my idea was to use some third-party library for that. So I thought maybe I can use some simple complexity metric. There are tons of them, like cyclomatic complexity,
Yes.
Halstead's volume metrics. The problem is when you look at these numbers and you start to control for the number of lines of code, these more elaborate metrics don't add any further predictive value. So complexity metrics are pretty bad at predicting complexity. And so I start to think that maybe we need to combine multiple measures because complexity is so multifaceted. And it turns out that it's really hard to define what good quality code is, but it's very simple to agree on what bad quality is, right?
Yeah.
So we start to look at the research and identifying all the factors that can contribute to bad code. So stuff like low cohesion, gut functions, overly long methods, deep nested complexity, copy paste, all of that. So we identified 25 different factors. And based on these 25 factors, we built an algorithm that can take a piece of code, analyze it for these code smells, and depending on their severity and presence, we can categorize every single piece of code on a 10-point scale. So that's roughly how it works. And that's the code health algorithm that we have been validating in our research, like CodeRed.
Yeah. And so, and then we are saying that red code is harder to develop for, and changes take more than 2 times. And are they also like less reliable, or there are other things you discover just as other than pure like average development time about working on code that is bad versus code that is good?
Oh yeah. So looking at the averages can be slightly misleading. So even if there's a strong difference there, an even more important difference is that in red code, task completion times vary a lot. They seem to be very unpredictable. And what we see in our data is that doing a task in unhealthy code can actually take up to an order of magnitude longer, 10 times longer. And that translates into a bunch of undesirable side effects for the business. So what you typically see when you have that type of code is that it becomes really hard to guess how long a task will take, right? I mean, software estimation is already a dark art. Now you add unhealthy code to the mix. And that in turn causes a lot of stress over time and missed deadlines for the organization. And it's also very stressful to the management level, because as managers, we might expect that a particular feature or capability is available at a given time. And now it turns out that you need it 10 times longer. So it causes a lot of harm.
Yeah, absolutely. And does this like performance, whether it takes like X or 10 times X, depend on, I don't know, other factors like who wrote the code, who works on the change? Could you correlate these issues and performance to other aspects that maybe you could get from version control history, for example?
Yeah, that's a great point. So me and my research colleague, Dr. Marcus Borg, we did a follow-up study where we looked at, does it make a difference who makes the change?
Yeah.
And it turns out that, yes, it has an impact. So let's pretend that I write some truly unhealthy code myself. I can make changes to that code. It's still going to be twice as expensive, but I can make changes fairly reliably.
Yeah.
If another developer comes in who might be more experienced than me but have never seen that code before, then they're going to need twice as long to make a similar change. So it seems that unhealthy code comes with a significant onboarding cost. And that's of course problematic because I'm not talking about bringing new people into the company or the team, right? I'm talking about the people that are already there and now
Yes.
have to work in a part of the code that they're not familiar with before. So there's
Yeah.
definitely a large hidden cost there as well.
Yeah. And how do you assess, let's say, knowledge of the code from people? Do you consider like the final version of the code who has written that, or you take into account that maybe one person had written a previous version and there were like a history of changes that were worked on by a number of people? How do you analyze that?
So we have tried multiple algorithms. The one we are using and have been using for the past 5 to 6 years is that we go deep into version control history. That's the beauty of version control, that it's also social data, right? It's knowledge data.
Yes.
And what we do is we look at the full history of every single file, trace it over renames and file moves and whatnot. And then the ownership is as a percentage of the historical contributions. And the reason we ended up with that and not just used a simple git blame or something is because git blame is quite shallow. So
Yeah.
let's say that I write a piece of code myself today. Tomorrow you decide to rewrite it. That doesn't mean that I lose all the knowledge because I have an understanding of the problem and there are probably some coding constructs remaining, right? So
Yes.
that's why we found better results with taking the full history into account.
Yeah, it's the equivalent, for authorship of the difference that you mentioned before for measuring, it's using static analysis versus looking at full version control history translated into this like kind of authorship domain.
Yeah, that's a good point.
So when we talked at the beginning, you said that by looking at version control history, you were able to spot patterns about development activities and what is the distribution of this activity across the code base, and look at and figure out what files and what parts of the code base got the most activity. So by looking at authors and what code gets written by whom, did you find similar patterns about like the distribution of like the impact that individual developers had, how this kind of knowledge distributes or concentrates in the code base and something like that?
Yes, you do find those patterns too, and it might be an inconvenient truth because companies don't like to hear it. But it turns out that almost all code bases, no matter how large the development team is, are quite exposed to a risk known as the bus factor. And the bus factor simply refers to how many people can leave your organization before the code gets unmaintainable. Not necessarily because the code is bad, but because you lost the detailed institutional knowledge of what it does and how it works, right?
Yeah.
And the numbers are surprising. I've been doing a number of presentations and case studies about it, but we also have real data. And it turns out that if you pick up on typical code base, say that you have a team of 50 people working on a couple of million lines of code, what you often find is that your bus factor might be as low as just 2-3 people, which is really, really scary.
Wow. Wow, it's so low, from 50 people to 2 to 3 people.
Yeah.
And
And
is that because these people actually write the most of the code, like they're way more productive in terms of pure output, or is it about, I don't know, maybe their code has way lower churn, for example, it doesn't need to be changed a lot over time versus other people's code, and so even if they produce like the same amount of code over time, the share of their code in the whole code base like increases more than other people. So does it work also like that?
yeah, I think there are multiple factors contributing to it. And I also think that having that type of key person exposure, it's of course a risk, but I would be even more worried if I didn't have any key persons, right?
Yes.
Because I do think that, or I think it's pretty well established that there are definitely individual differences in our capabilities as developers. But I also think that if you have been along from the very start of a particular project or a code base, then at the beginning you typically create way more code. You're way more productive because you don't have any customer requests, you don't have any support issues. The field is pretty much laid out for you. So at the beginning you can typically create a lot of code. So it tends to be long-term contributors, also meaning that they sit on a lot of history and decisions. So they have a lot of that knowledge. And then add in a possible productivity factor, and yes, that's where you end up with the buzz factor.
Yeah. How do you reduce this risk, the risk that comes with the buzz factor, or do you think it's just a fact of life and there is not much that we can do about it?
No, I think like all risks in software development, we should pay attention to it and we should try to mitigate it. So what I try to do is that we use a combination of 3 different factors in CodeScene. So we have a specific buzz factor analysis, and what you can do there is simply you can see if the buzz hits, which areas are going to get impacted. And that's an important first step because it gets the attention to the potential risk. The next thing you want to do is you want to add in those technical metrics that we touched upon earlier. So you want to know if any of those impacted areas, how volatile are they? Are they a hotspot or is it stable code? If it's stable code, I would worry less. If it's a hotspot, it means that it's a massive risk, right? Because it means that area of the code is under active development, so it's urgent. And if it also has low code health, then you know that there's an additional onboarding cost. So when I find that a piece of code ticks all these 3 boxes, then I would like to act. And what I typically recommend is to try to take one of these people that have all this knowledge and pair them together with someone else from the team and have them refactor the code together. Yeah. Because by doing so, not only are you going to distribute the knowledge of that part of the code, what you also do is you reduce that further offboarding risk, since the code is now easier to understand. So sometimes when it comes to technical debt, the buzz factor might be another driver behind refactoring a piece of code, not just the code complexity in isolation.
Yeah, I love that this analysis makes it very practical and, you know, presents with hard numbers, things that usually are very hard to uncover and for which, you know, many mitigation strategies are hard to advocate for. I mean, I'm thinking of better code reviews or pair programming. I mean, things that we know, you know, from a qualitative point of view that they are good for this kind of intangible reasons, but sometimes they are hard to advocate for because you cannot bring easily data to support this, which is instead what it looks like now. I mean, if you can demonstrate that there is a high risk because we have large parts of the code base that get changed all the time, but they're known just by a couple of people in the company out of 50 engineers. I think that's pretty convincing that I know the development process should take into account how the knowledge gets shared across the team.
Yeah, and I think that's important. It has been a personal mission of mine to make software development a bit more objective. It turns out we actually have a lot of data in research. There is so much research on software where the research community actually knows things and can prove things, right? And yet software development is quite opinionated. I mean, we are more fashion driven than the catwalk in Milano, right? And
yes,
I should know that because I'm a software developer myself, and I try to avoid these traps, but I fall into them every now and then. So that's why we decided in CodeScene everything we do will be supported by data. And I hope if there's one big lasting contribution, then it is that technical debt management and all of that can be much more data driven. It doesn't have to be subjective and based on speculations.
Yeah. So it feels like your research, just like as you mentioned, all the research that has been around for a long time, basically validates things that we have known for a long time, but in many cases we have chosen to avoid or to ignore. But basically, the good practices that surface from this kind of analysis are the things that we should always have known right? So that align with what we believe is good software engineering? Or is there anything surprising, you should say, that you did not expect coming from your research?
So no, I don't think there was anything. If there was one thing that surprised me, then it's how strong these signals are, right?
Yeah.
So good and solid engineering practices, they are so important, right? And when we violate them, we pay the price, and that price is often much more expensive than we think, because
Yes.
we usually don't see the root cause. We see symptoms like I talked about earlier, delayed projects, not living up to expectations, and that's painful to the business. But the real problem is probably much more expensive. All that waste is it usually lacks visibility, which is why organizations tend to ignore it, in my opinion.
Yeah, I would have answered kind of the same for myself if I asked myself the same question. That is, what was the most surprising from this chat with you so far? Would have been not necessarily, the direction of many of the findings, like the fact that there is a power law in, I don't know, software development activity on in the code base or the bus factors, but how extreme this, this power distribution is, like the fact that 50 engineers, bus factor is like 2 to 3 engineers, or 90% of development gets concentrated in 10% or 5% of the code base. I think anyone who has written, who is a software engineer or has worked in this space for quite some time, could have guessed, that there was a power law happening. But I mean, I challenge anybody to come up with such a steep number.
Yeah, I agree. And I mean, the thing is that the rate of change in software, it's so rapid. So without proper tooling and techniques, it's virtually impossible to stay on top of it as a human. And I
Yeah.
kind of noticed that because, when I sit down with a customer or I analyze a code base myself, what I always see the first time I look at it is that the code has deteriorated. So the code is almost always in a much worse shape today than it was a year ago. So that's also kind of interesting, right? That if we don't act, then the entropy will increase.
Oh, this is so interesting. So basically, another byproduct of looking at version control history is that you can plot the trajectory, right? You sit down with customers and you can not only tell them, the code health and the amount of risk that you're now facing is X, but also that 1 year ago it was better, 2 years ago it was even better, and so if you think about 1 year from now, it will probably be worse than that. So is that always the case? I mean, most of the times code bases just get worse and do not get better.
Yeah, it is. And it's actually based on an old observation from academia known as Lehman's laws.
Yeah.
So I think they're from 1980. And one of the laws is called the law of increasing complexity, where Manny Lehman, the author, claims that software, unless we actively try to reduce complexity, the complexity will just increase. And I have seen that myself throughout the past decade. And I think it's important because that's the beauty of version control data, right? As you point out, that you can go back in time. So you don't have to run and collect data for 5 years to see a long-term trend. You can do it immediately. And it's
Yeah.
powerful because trends are more important than absolute values. So a value without a trajectory or without context is entirely meaningless because it doesn't tell you if you should celebrate or cry.
Yeah. Yeah. I mean, if you look at an absolute value, knowing that you're getting there from a trajectory of improvement over the past, I don't know, 2 years, it's a totally different story than if you got there getting worse and worse year after
Yeah.
year. Yeah. So I want to segue into something else that is, I mean, but these days no interview, I mean, can be completed without talking about AI. And what fascinates me in relation to your work is that both your code as a crime scene and CodeScene itself greatly like predate the AI shift, right? But this kind of reasoning, this kind of analysis feels like it should be AI's bread and butter, right? So has AI improved these kind of capabilities for understanding code health? Can we figure out more today than we could like 2 years before from code?
So the depressing answer is no. I don't think AI has improved on that. What I think AI has
Love
done, I
this
mean, the
answer already.
mainstream, the mainstream adoption of AI, what it has done is that it has put additional emphasis on strong engineering principles and practices. I think it's even more important today than it was pre-AI.
Okay.
And
Okay.
I think the reason for that is that, in fact, when I wrote the second edition of Your Code is Crime Scene, so I did an update in 2022. I was
Yeah.
just wrapping it up, going through the final edits, and then ChatGPT was released, and GitHub Copilot took off.
Yes.
And I kind of thought, if I write a book about maintainable code, I need to include something on AI. So I added something in the last chapter there, a forward-looking piece. And what I wrote back then was that I think that using AI to write more code faster is a very impressive solution to the wrong problem. And the reason I wrote that is because AI today is pretty good at generating a boilerplate code. It can do it really, really quickly. The main problem is that writing code is not a bottleneck for a developer. As a developer, we spend 5, maximum 10% of our work week writing code. The majority of the time, the big 70% are spent on trying to understand what's already there. And it doesn't matter if it's AI or human generated.
Yeah.
Understanding is the big bottleneck in programming.
Yeah. And so have you found that under the assumption that AI is writing or will write a good chunk of our code, any of these factors, any of the things that we should take into account about complexity, code health, and risk change because we need to optimize things for AI a little bit different than for humans? Or, you know, stuff that is good for humans is largely also good for AI?
Yeah, definitely. There is this interesting observation. I think it's even on Thoughtworks' latest technology radar, the concept of AI-friendly code. And it turns out that code that's optimized for a human brain also works wonderfully for an AI. An AI benefits a lot from additional structure, from clear naming, intent expressed in variables, function declarations, and so on. So it turns out that the better your code is, the more you get out of the AI. And that's kind of interesting because those companies that are trapped in legacy code, trapped in technical debt, it might actually be that they are not AI ready. They might not be in a point where they can apply AI securely and reliably, right? So maybe this whole AI trend can help shine a light on the importance of high quality code and technical debt remediations.
Yeah, I love this. This is not the first time that I hear this, and I actually love this direction because I mean it was not necessarily the case, right? That the way we work on code and the things that we believe are good for humans necessarily translate into things that are good for AI. But I think it's awesome that it is turning out to be that way because it's like the ROI, of good engineering just increased a lot, versus the cost that has stayed the same, or in many cases maybe it got a little lower because now AI is helping us. So maybe it's going to be AI to convince us to do better engineering, and it would be a little bit ironic, but welcome nevertheless.
Yeah, it might be the final push. And I think it's an important one because no matter what happens with AI next, no matter how far we take it, I'm pretty convinced that we will see a hybrid model of the next decade, right? Where you have code written by both humans and machines.
Yeah.
And both audiences need to understand it, right?
Yeah.
So in addition to just please the machine where you're going to execute the hardware, you also need to piece your AI agents and the human maintainers. So software today is probably more challenging than it ever was before, even if our tools are more powerful than ever.
Yeah. So from your privileged point of view of analyzing many code bases and working with many customers, do you feel like AI coding is already having a strong impact on especially on established companies, or is still, I mean, the jury has still undecided, and it's more FOMO than actual impact?
So let me see how I should answer that. So it's kind of interesting because everyone talks about adopting AI, but
Yeah.
many organizations haven't done it yet.
Hmm.
And I do see it. It's definitely mainstream. It's out there. Does it help with writing better code? I haven't seen any convincing evidence so far. It can
Hmm.
definitely help to prototype quickly. It can definitely help with mundane tasks. But there's also some evidence mounting to the contrary that uh, the most surprising one is on a study I saw last week that pointed out that AI, in this case, I think it was Cursor that they used in the study, made the developers 20% slower at fixing bugs in an
Yes,
open
I
source
saw
project. So
that.
that really surprised me, right? So I think it's important to continue to study this. That said, I think AI has a massive potential, but I think we need to rethink it and reapply it and focus it on the problem of making code easier to understand rather than generate more of it, because that's not the bottleneck. So
Yeah.
that's the direction we go with my company.
Yeah, I think that's a great takeaway. I think so. If we had to summarize it in one sentence, is AI can be great, but not at the things that you may initially expect. I mean, not necessarily at writing more code, but helping you like reduce maybe cognitive load and work easier. But the bottleneck has never been right typing faster on the keyboard. Let's say.
No, exactly. That's a great summary.
Yeah. So so far we have discussed all these elements about uh, technical debt, analyzing health and complexity of the code that's already there, and paying down this kind of debt and repairing at the damage that has been done. So it's basically detection and repair. But uh, can you prevent some of this complexity and damage to happen? So how do you prevent the accumulation of this debt, and how do you prevent this degradation of code base instead of just having to intervene when things are already bad?
Yeah, that's interesting, and this might even be more important than starting to remediating existing technical debt. If we can prevent new technical debt from entering the code base, then we're probably already doing a better job than 80% of all organizations out there.
Yeah.
So this is something that we have put a lot of effort into with the company. So one thing we do is that we integrate code health reviews completely automated into pull requests. So the
Okay.
moment you open a pull request, you see if your changes had any adverse effects on the code health. So if it had, then you can go back to a drawing board and remediate that, and you will always merge healthy code, which I think is important. And over the past year, we took it one step further because, yeah, let's be honest, the pull request is pretty late in the process, right? So now we have ID extensions. So when I code, if I want to, I can get code health information close to real time. So I can immediately see if my changes introduce some cognitive load or if it had a adverse effect on code health.
Yeah.
And what I think is interesting is the stuff we've been working on over the past year. We've been developing a refactoring agent called ACE that I think fits quite naturally in that workflow, right? So when I code and I see that a function or a file seems to decline in code health, then I can ask the AI to propose a better solution for me. And that's where I think AI can really help, because it can it can serve as a learning vehicle, right? That exposes me to better ways of writing the code. And then I can choose to accept AI suggestion, or I can use it as an inspiration. But it simply means that whatever I merge will always be slightly better than what I had before.
Yeah, I love this direction and the progression, and how you got to integrating things directly in the IDE. I think if I look at the developer tool space, uh, I think there is this distinctive trend of shifting things more and more to the left. And many tools started as pure dashboards, where you could look at numbers like asynchronously to when you ship code and write code. And then this kind of analysis got into the CI/CD, pull request time to get you signal. And then many of these are shifting from CI/CD to straight into the IDE because of course the earlier you can intercept this stuff, the better. Is that how you think about it?
Yeah, that's very much how I think about it. I keep thinking about it as a important feedback loop, almost
Yeah.
like a self-reinforcing feedback loop. Because as a manager, if you invest in a tool, you look at the dashboard and you expect to be able to see some kind of return on investment on that tool. That has become more and more important, right? But you're
Yes.
not getting a return on investment unless your development teams act.
Yeah.
So if you can get developers to, if you can simplify the life of a developer and make it easier for them to manage technical debt and improve code health, then not only is my life as a developer is going to be better because my development is more predictable, more enjoyable, but I'm also going
Yeah.
to improve the life of my manager because they're now going to be able to, reap all these benefits of healthy code, ship faster, fewer defects. So I think that's really, really important. It all connects together in a system, and it definitely starts with the code we write today.
Yeah. So the code we write today is basically the daily version of taking care of code quality and code health. Are there other, like maybe more aggregated version of data or parts of this analysis that you recommend teams to work on maybe on a weekly basis or on a monthly basis in a retrospective? How do you embed this information into team ceremonies?
Oh yeah, that's a great question. So what I recommend is always start by putting a safety net on your code. So you know, integrate this pull request check. That gives you a safety net because preventing new technical debt is really step 0 in managing it. Then the next thing I recommend, start out by doing a deeper dive, understand where your hotspots are, and understand why they are hotspots, and understanding which direction they are trending, and then plan the remediation. So either plan to refactor them or just put a bar on them and say that, okay, we can live with what's there, but we don't want it to get worse.
Yeah.
After that, what I recommend is to make these analyses a habit. So tie them into some existing ceremony or activity that you already have, like maybe pick 2 daily stand-ups a week, Tuesday and Thursday. And what you will see is that once you get used to these core metrics of hotspots and code health, then you will be able to look at the dashboard, and within seconds you can see, is there anything that requires my attention? And then that's your chance to discuss it with the team. If not, then you can usually move on and you can be confident that everything is on track. So making that habit and having that safety net, that would be my key recommendations.
That's perfect. So thank you, Adam, for the great chat. I loved it. Took a lot of notes, and thank you again for coming on the show.
Yeah, thanks a lot for having me here, and thanks for the great conversation.
Thank you so much for listening. If you found this chat valuable, you can subscribe to the show on YouTube, Apple Podcasts, Spotify, or your favorite podcast app. Also, please consider giving us a rating or leaving a review, as that really helps other listeners find the show. You can find all past episodes and learn more about the show at refactoring.fm. See you in the next episode.